Just a quick sort of show of hands or a couple of questions from the audience. How many of you have actually seen a video of me doing this talk at any point? Anyone? A few of you, okay. There are some nuances, and because I'm giving it live, it'll be a tiny bit different, but you'll see the gist of the argument. How many of you are using test-driven development today? Test first or test after? Okay. How many of you are doing it, test first? All right. And how many of you are using, say, mocking techniques and mocks? Okay, loads of you. Okay. All right, interesting. Okay, so this is me. Most of that is dull and uninteresting. The bit that I usually draw attention to is the last point on that slide, which is people like me come and talk at conferences and stand in front of you. We're not necessarily smarter or cleverer than any of you guys. And, I'd really encourage all of you to get up and speak at conferences if you can, contribute back to the community. That's all I'm doing, is I'm just a developer like you who decided to try and share some of my ideas with everybody else. I kind of got forced into it because back when .NET first started, there were very few people, there were very few experts. And so as such, if you wanted to run a meetup or a user group, you had to kind of stand up and do it yourself. But I'd encourage all of you to get involved if you can. It's a great way of personal growth for you as a developer in terms of learning to express your ideas more clearly. That's what I work for. I work for Huddle. It's not really that exciting. We are hiring, by the way, but it's not really that exciting for you, other than just to say we are a SaaS software business. I have nothing to sell you, right? You can't buy my services. So all of the ideas here are based simply on my experience that I'm trying to share with you, not on me trying to basically market anything to you. What are we going to talk about today? So I want to talk about what I perceive as being the problem with how people are practicing TDD today, and why there has been growing resistance to TDD. I want to then look at rebooting our TDD practice, taking us back really to where we started from, and looking again at ideas like red-green refactor, clean code, refactoring, etc., to understand how those ideas should be applied and where we may have made mistakes in our practice that have led us to adverse ways of doing TDD. And then I'll talk about some ideas that can help, ports and adapters, gears, look at what ATD and behavior-driven development give us, and mocks. It's quite a lot to get through. Some of the later sections we may go a little bit faster on, depending on time. So we'll try and focus on the early sections. First thing I want to do is talk about the problem. Now, I've been practicing TDD since about 2004. In London, the .NET community were quite early adopters of test-driven development, just simply because we had close relationships with an XP group that used to meet in London and a lot of cross-fertilization of ideas. And so we've been practicing TDD for quite a while. And I first gave this talk in about 2013. So I've been roughly 10 years I've been doing TDD. And I had come to the conclusion after owning TDD-produced test suites for a while that there were some problems with what we were doing. And one of my things is that I tend to try, particularly since I've become a software architect, try and stay at companies long enough to see my own mistakes come back to meet me. It's a very humbling thing to do, but it's also how you gain kind of a lot of value from your experience. If you stay somewhere 2 years, quite often the problem is that you don't ever, you finish implementing something, you're very proud of this great work you've given and you've done, and you move off. And you never find out what were all the things that you actually did wrong that later developers went right about. So if you stay a bit longer, quite often you find what goes wrong. And I'd written quite extensive test suites, and I found some of them were very difficult and very expensive to own. So let's kind of talk about my understanding of TDD and how it's shifted over the years. Okay. So the first thing was, back in sort of 2005, 2006, when I was first having drunk the Kool-Aid on TDD, first practicing TDD, I found quite a lot of resistance to test-driven development. A lot of people were saying, we don't want to do this, this is a crazy idea. And I was very much, you just don't get it. You just don't get what the rest of us get. This is the best change in development practice I've seen in the last 10 years. You guys need to be doing TDD, you just don't get it. But still there are people saying, I'm not really sure about this TDD. And the crazy thing is, a lot of those guys were really quite smart developers who I respected. You know, these were guys who wrote really good code. And yet they were saying to me, this TDD thing, it's not the right way to develop software. And you know, the more they said this, the more I just kept repeating the TDD mantras, as if, like a child, if I just kept speaking slowly and carefully and repeating how TDD worked, eventually the light bulb would go off and they would appreciate the glory that was TDD. But a few of them just seemed to resist. And I can remember one of them, a really smart developer who I really admired his work, said to me one time, "It's okay," and I finally got it. And I was like, great. And he said, the junior developers, they need TDD. It really helps them. I can see how it helps them write good code. But surely you don't really expect the experienced developers on the team to be doing TDD, right? And I was really puzzled. I couldn't really understand, what is this guy getting at? A couple of times, we're very proud of the fact that we produced some code that went into production with almost 0 defects. So there was no UI involved, we made that a bit easier. But one time I worked on a back-end service, and that went into production, and for a year there were no reported defects. Worked exactly as expected. We were very proud, and we put down the way this had worked to TDD. We had a fantastic test suite. We knew all the scenarios we were going to operate under, and provably our code worked. And when I looked at this test suite, one of the things I noticed was that we had about 3 times as much test code as production code. And I can remember being a little bit, is this right? So I went on to Twitter, source of all answers to all questions in life and the universe, the source of truth and wisdom. And I said to Twitter, is this right? You know, and other people said, yeah, no, we quite often have, 2 or 3 times the amount of test code that we have basically as actual production code. And I was thinking, it's okay, but it feels a bit puzzling. One of the problems with this is you quite often got the situation where, some project manager would turn around and say, guys, look, couldn't we just skip the tests? We've done so much faster. We get out to market a lot faster. I know you guys like doing good engineering, etc., and I really get that. But it's taking us an awfully long time to write all these tests. Couldn't we just ship the code? It wouldn't really matter if there were a few defects, in production, right? Can we just not do the test? And we'd say, no, you don't understand. The way we write code is by writing tests. We can no more stop writing the tests than we can write. This is our, the standard mantra, effectively. Tests are part of our practice of writing code. You're just telling us to stop writing code if you do that. And they'd go away going, okay, fair enough. We get it. You guys want to write tests. But we were slower. I mean, that's just the reality. We were, 20 to 50% slower than we had been before by writing tests. The other thing I noticed over time was with some of these big test suites is that when we wanted to change something, we'd quite often break a lot of the tests. And quite often, what we were doing was simply refactoring. We were going, oh, well, we've added some new features to the code, and now the shape of the implementation is a bit wrong given these new features. And I can think of a better way of organizing our code, make it more maintainable. So I'm going to refactor the way the code is organized. I don't want to change the behavior of the system, I just want to refactor the shape of the code so that essentially it's more efficient. And a whole lot of tests would break. And a lot of the time, the tests that broke were the ones that were heavily mocked. Because these mocks were telling us exactly what ought to be happening in the calendar test. They were saying, oh, first you should be calling this twice, then call this, and then call this and put these parameters on it. When we refactor something, we quite often changed how that worked, and all these tests with mocks, they broke, and we had to rewrite all the mocks. This was kind of puzzling, right? Because the promise was that we should be able to refactor our code, keep it basically fit and clean. We wouldn't get into a big ball of mud craziness. We wouldn't really see our code rot before us, because our tests would enable us to refactor, and refactoring kept our code healthy. When we wanted to change our code, actually the tests were an obstacle to that change, because they increased the amount of effort we had to put into making any changes, because we had to fix all these tests that were breaking when we changed our implementation details. And that didn't sound right, because surely what Martin Fowler and Kent Beck were telling us about refactoring was that refactoring was changing the implementation details without breaking tests. Yet our tests were breaking all the time. The other thing we began to notice was, I guess it's about 2009, 2010, a whole lot of methodologies began to emerge that explicitly said don't do test-driven development. Because test-driven development slows you down. So there's programmer anarchy. Anyone know what programmer anarchy is? You got that reached over here? All right. A guy called Fred George. Fred George essentially said, for those of you that understand Spinal Tap references, he said, if XP is good, let's turn the dials on XP up to 11. Let's do extreme programming. Let's basically fire everybody who isn't a software developer, fire the QA, fire the product guy, just have developers talking to customers. And what we'll do is we'll write really small pieces of code, we'll call them microservices. They'll only have about 100 lines. So different schools of microservices, this is the original one. About 100 lines of code. They won't have any tests, because it's such a small amount of code, you're bound to get it right. We'll put it into production. If we want to change it, we'll just throw it away and rewrite it. Okay. Protocol program anarchy. But there are other things like spike and stabilize, but even lean software development, which became the real, go-to approach of the California, the Silicon Valley startup, was saying, don't do tests, right? Ship working code to customers, get it out there, fast as you can, get feedback, because you may be building the wrong thing altogether. You may want to throw it away. TDD is a kind of practice you do later on when you're scaling, right? But don't do tests, it slows you down too much. So there's this whole pressure saying TDD is a bad idea because TDD really slows you down. And you're better off just getting feedback. You guys have the expression over here, duct-tape programmer? Maybe. So duct-tape programmer is this really annoying guy, right? And every organization has one. And he's the guy the business or the product team absolutely love because he just gives them solutions as fast as he can. And as a requirement comes out, and they say, let's give it to Bob. Bob will just get it out the door really fast. And the rest of the team are going, but this is crazy. And at lunch, you're going, we hate Bob. Bob's engineering is rubbish. We spend all this time maintaining the stuff that Bob's written and having to rewrite it. And it's really annoying because Bob gets all the credit, right, from the product guy. The guy's going, Bob's fantastic. He's so receptive to our ideas. He just pushes stuff out. And the rest of you going, but it's so hard to maintain Bob's code. It's terrible, right? But they love Bob because Bob delivers for them. You're still writing your test suite, and Bob's shipped the code, and it's running. Okay? And we had a few of those, and it used to be really annoying. It used to be really annoying that we were still doing our best engineering practices, and these guys were shipping code. And it was awful code, but they were shipping, right? And so they won the credibility, not us. Sometimes, when we used to come back to our tests, when they were breaking, quite often because we were trying to change implementation details, we'd realize that we had no idea what the test was doing. Anyone had this experience? You go back and find the test is red, and you're looking at it and you're going, I have no idea what this test is for, and I have no idea whether the fact that it's red is good or bad at this point in time. Okay? This test seems to add two numbers and come to a result which I can't possibly understand how they could have originally ever got that result and why this test was originally passing. And now I've refactored it and it's read, surely just because the test is wrong. But lots of tests just don't really give you any information, especially the ones that are like swarm with mocks, and you're kind of like, what is actually under test here? They don't have that experience. They've looked at the test and they finally realized nothing is actually being tested apart from the mocks. Right? Someone's written this thing and mocked it so heavily you go, there's no real code actually under test here. Okay, and that experience basically began to drive us mad. We're like, well, I no longer know what this test is for. The best thing for me to do is just to delete this test because it's broken and I don't know why. Okay. I made, to my shame, a team I worked for embrace fitness. And we sat down and produced basically these loving tables in HTML, and they used them to drive our software. And eventually, these little tests would show up, the page would show up green, so that we could say, yes, these high-level tests that are written in natural English so the customer can understand them, these tests basically demonstrate that our software does exactly what we say it does on the can. And SpecFlow, Cucumber, these tools are all the same kind of thing. The idea essentially that I will write tests that the customer can just flick through the HTML pages, see the requirement that we've implemented, feel confident that the system does exactly what he specified. Because we can press the button and see it all go green. Ah, the software runs exactly as I expect. The guys basically hated writing these tests because they'd start out effectively and they'll be red at the beginning of the iteration. So they'd be red for a lot of the iteration until eventually they would go green when you'd done the implementation. And that meant essentially your fitness test suite was quite often, well, correctly red for much of the iteration. So you could never really be sure if the tests were red. Is that because it's yet to be implemented, or is that because essentially we've broken it? And so the thing that happened was a lot of the time the tests were red because we just assumed, oh, they're red because they're not implemented yet, when in fact they were broken. So they spent a lot of their time as broken test suites. The customers never really looked at this stuff, right? We built these customer-facing tests, but it was very rare to get the customers to actually come along and flip through the HTML pages and say, I'm so impressed, guys. I can see exactly the requirements that I want. I can see them written in a natural language, and I can see that it works, right? Occasionally we try and sit them down and make them look at the screen, and they go, maybe, how about put something in my calendar, guys, and we'll talk about this at some point in the future, right? And they were completely uninterested in seeing these test suites that we'd written to prove to them that the code worked correctly for them. And the check-in dance became more complicated because as well as passing the developer tests, you had to run all these fitness test suites before we allowed you essentially to check your test into the code base. And they took a while to run, they were slow, and that meant essentially you go off and make your cup of coffee and come back essentially because really, you know, so then you'd lose track of where you were and what you were doing, and the whole flow of your coding session was broken because now you're in that classic developer situation where it takes you 20 minutes to really get my head around the code that I'm working on, and then I'm in the groove and I'm working on it, but now I've forced an interruption to your process, which is going to mean that you stop working effectively during that time period. Okay. So it became a really inefficient way of doing it, and the developers just really hated doing it, and they started to ignore them, right? If we just basically keep going and checking code in, eventually Ian will notice the tests are all red and go, my God, the tests are all red again, sort of thing, and then we'll have to basically down tools and fix them. But until then, we can keep moving. Right? And then what would happen is somewhere would always be plausible deniability, right? My test didn't make that go red. Mine changed, that wasn't my change, that was Dave's change. Then you used to have somebody appointed on the team whose job was to essentially determine who had broken the tests and made them go red. And then that person would essentially blame, you know, apportion blame to the person that had to go and fix it, right? The fact that we actually had a step in our process, which essentially was somebody decides who's to blame for the test being read today, and then they're going to have to go and fix them, implies that no one really cared about those tests because they'd reached that point of being read the whole time. And really, the developers couldn't see any value. They constantly resisted writing these tests. And one thing I've learned over time is that, you know, if an idea actually really works, after a while, your team will be quite happily behind it and enthusiastic supporters of it. If your team is constantly pushing back, saying, really? I don't see what I'm getting from this. I don't see the value in the test that you're forcing me to write. Then maybe you need to think again about what you're doing. Okay. About a year after I gave this talk for the first time, DHH, the guy that created Rails, posted this blog post. TDD is dead long-lived testing. And a lot of what his complaint was I am being forced by people people tell me that Rails is wrong because Rails doesn't work the way they think test-friendly framework should work. So he said, you know, I have the active record pattern in Rails. And an active record pattern, those who don't know, effectively the data persistence methods are actually on the object that you're persisting. So your user object has a persistence method on it for object. And so people tell me this is no good because they can't cleanly separate their domain object models from basically their testing framework. And he said, I just used to write my unit tests, and I talk to the database. And I'm now told that's wrong as well. And he said, I used to like TDD when it first came out, but now I'm constantly being told I'm doing TDD wrong. then I'm just giving up on TDD. You know, TDD, as far as I'm concerned, doesn't work. I'm still going to do some testing, but I'm quitting on TDD. And of course, such a stir that Kent Beck kind of responded, saying, you know, RIP TDD. It was quite a sarcastic post, which may not have been the best choice when Americans are amongst your audience. But he kind of said, you know, oh, well, here's all the things I'm not going to be able to do now I don't have TDD anymore. So it was kind of defense of TDD. And Martin Fowler actually produced this series of dialogues mediated them between Kent and DHH, talking about TDD. DHH went and saw an original version of this talk that I gave at NDC and was kind of saying, yeah, I think you and I are on the same lines. And they came to a pretty similar conclusion as the rest of this talk. So you might want to go away if you like the ideas here and go and see Kent and DHH having this dialogue mediated by Martin about what they think happened. But the question is kind of where did it all go wrong, right? What went wrong for TDD and can we fix it? Can we change our ways? Anyone know, anyone ever here ever called of an English footballer called George Best? No, most of you probably don't know. It's very, very famous in, given my age, in the 1970s. And a story goes that a bellboy at the hotel enters George's room in the hotel. George is lying on the bed naked with a couple of supermodels. The bellboy is wheeling in the caviar and champagne that he's going to give to George and these naked supermodels on the bed. And the bellboy looks down at George and says, George, where did it all go wrong? And so take that sentence in that kind of light, right? I am a fan of TDD. What I want to talk about is, you know, where did it all go wrong? Okay. So what I want to do really is go back to the beginning. I want to go back to the beginning of TDD, and I want to explain to you, the premise of my argument is TDD has answers to all the problems that we have been meeting with TDD. We have just ignored the fact that basically the original approach to TDD, as described by Kent Beck, works. Later patterns and practices we have loaded onto TDD may in many cases a mistake and have led us away from what was originally intended and our mistake. So I would recommend, who's read this book? Okay. Many more of you practice TDD than ever read this book. Who's read some other book to learn about TDD? Who was told how to do TDD by somebody else that worked near them? Yeah, probably more of you. Okay. I would recommend reading this book. If you practice test-driven development and you want to understand how it works, I'd recommend reading this book. When I began to struggle with TDD, I went back to read, I haven't read this book again, I read it originally. I went back to read this book again, and one of the things I learned was that Kent had an enormous amount of wisdom about TDD, having practiced TDD for a large number of years before he read the book. And many of the problems I was encountering with TDD, Kent had already encountered, understood, and were discussed in this book. Okay? And this book, although it seems old, covers all sorts of things like mocking, ATDD, which many people think, oh, they're much later. They're much later developments. They happened a lot later in life cycle. They're all in here. Right? And this book is probably the only wisdom you need, but I don't think I understood much of its wisdom until I'd been doing TDD for a certain amount of time, and I was then able to understand what Kent was trying to tell me. Okay. I think the most important thing to take away from an understanding of that book is this. Okay? When you are practicing test-driven development, do not test implementation details, test behaviors. I will explain that sentence more as we go through this talk. That is the key thing that people get wrong today. So what happens is a classic modern TDD cycle. Someone says, I'm about to write a method on a class. I will write a test before I write that method, and that test will govern whether that method succeeds or fails. And so the trigger to writing a test in TDD practice is essentially adding a method to a class. That is the wrong thing. Okay. That is not the ethos of TDD. The trigger in TDD for creating a new test is that you have a requirement you want to implement. It is nothing more, it is nothing less. Okay? There is something I want the software to do, I will write a test to do that. Okay? I want basically the software to add an amount to this customer's bank account, essentially, right? I want the software to upload a new file to the user's collection of files, right? That's what drives a test in TDD. That's what you are writing tests for. You're not writing tests to say the foo method should take the two numbers, multiply them, and return the result. Okay? That is an implementation detail. There is no requirement you received, well, probably not necessarily a calculator, no requirement you received that gave you that. The requirement you received was something else, much higher up, right? And that is where you write the tests. What you want to be doing is focusing on testing the API of your software. Okay? When we talk about the API, we're talking, we'll clarify that in a second, but we mean, what is the contract your software has with the world? What does it offer to do for people who are basically consuming your software? That is the stable idea of your software. It will not change that rapidly. You may add new stuff to it, etc. But it's a stable requirement that you have. How you implement that requirement is unstable. You may get better ideas over time, and you may wish to change it. But what your software offers to consumers is the stable contract, and that is what you should test. We don't necessarily, by the way, mean by this an HTTP JSON API, right? So when I'm conscious nowadays, when I use the word API, everyone imagines, you know, REST, HTTP, JSON, GraphQL, whatever, essentially, right? What we mean simply by an HTTP API really, or by an API really, is just the publicly exposed surface area of your module, generally, that somebody else is consuming. So in the classical description of a module, module has basically a set of exports, public-facing things that other consumers can call, other software can call, and internal implementation details that you've hidden away. These are these classic notions of information hiding, encapsulation, right? Your module has a facade, something on the outside that essentially hides all those details away. And it is that external set of exports that you are interested in testing, not the implementation details which tell you how you are implementing that. Okay. What happens is we should get some use cases or a story in a kind of agile environment, and that says, here is the requirement I want you to implement, here is the story, here is the use case, here is the thing that your software is supposed to be doing, and you write tests to say, right, I'm going to write a test to prove I can do that. And generally speaking, there are good models for this, like given, when, then, given that my account has £100 in it, when I add another £100 to it, then I have a total of £200, right? That is a kind of classical requirement trying to implement. Now, I may end up using objects to represent accounts and that kind of thing, but what I'm doing is saying my requirement is the behavior of my account and how it behaves when I add or remove things from it. Okay. The system under test is not a class. Too much TDD practice focuses on essentially writing tests for classes. Okay? The system under test is really the exports from a module, its facade. When people talk about this phrase unit testing, at the time that people were basically coming up with this kind of idea, to them, classical testing paradigms, a unit test was a test of a module, right? It's kind of a black box where effectively you talk to basically what it exposed. Now, there's a certain line between classes and modules where effectively people can say, well, a class is a module, it's information hiding, encapsulation, etc., that kind of thing. And I appreciate that. But the definition of unit has become too much fixated on being a class. And people talk about isolating that class and isolating the class's dependencies, right? That leads you into all sorts of problems, because then you start mocking heavily, which leads you into what we call overspecified tests, where essentially you know all about the internal implementation details of that class through your mocks and how they are called, and essentially you've hidden no implementation details. So you want to focus at a much higher level. You want to say, I have some public things that this module does. That's what I'm going to test. I have some implementation details, and I'm not going to test those. Okay? And we will explain how to get there. TDD explains exactly how to get there. This may sound complicated, but there is an easy route to get there. Okay? So obviously, you may actually be driving a class, because if you're writing, say, C# or Java, you can only drive classes. But that class may tend to be a facade or a command or et cetera, some kind of interface to the actual module underneath. You don't want to write tests to cover implementation details because of those change. Okay? You want to write tests for your stable contract, which is essentially your exports from your module, your API. Refactoring is the key step which enables you to achieve this goal of separating between things that are implementation details that you don't need to test and things that you do need to test. Okay. There is a get-out clause, and the get-out clause says sometimes it's helpful to probe the implementation details because they're difficult to understand. You can do that, but delete the test afterwards. Again, we'll come back to that. So a lot of these ideas, I'll explain in more detail as we go through. I want to give a bit of a props here to Dan. So Dan wrote a post about what he called behavior-driven development. Now that's turned into something else, really, that has the same origin point, the same root. This is the root of that. When people talk about behavior-driven development today, they mean something else entirely. We'll talk about that later. But in his original post, Dan said, I often find when I go to basically implement TDD in places, people are very confused about how to do TDD because of the word test. The word test throws them. And if I change that word to behavior, drive the development of your system using behaviors, people do it correctly. And this insight is very old, right? I can't remember when this was, basically 2005, something like that, etc. And he's saying exactly what, really, I'm going to tell you in this talk. People misunderstood what Kent was talking about, probably because Kent used classical testing terminology like test, unit test. I mean, he mentions unit test a couple of times in the book. Generally, the phrase Kent Beck uses developer test, right? Not unit testing, developer tests. But Dan basically effectively recognized the same problem I'm recognizing here, which is people were driving tests by saying, I need to test this method. They should have been saying, there's a behavior in the system, and I want to use code to basically prove that that behavior works in the system. Okay. So in case you think that's just a Dan thing, Kent wasn't talking about this. Just Kent Beck originally. Kent's talking about behaviors. Behaviors would demonstrate we're confident we will compute the report correctly. So he's saying the object of TDD is to test behaviors in the system. Okay. Here is a classic thing that you are testing. Add amounts in two different currencies, convert the result to a given set of exchange rates. We are not testing a method on a class. We are testing a behavior of the system that we can add two different amounts in two different currencies and then see basically the result in one currency. Okay. We are multiplying a price per share by a number of shares to receive an amount. Okay? The behavior is the requirement. These are TDD requirements as described by Kent Beck originally. Right? That is what your test should be looking at. Not, I need a method in my class for exchange rates. That's nothing. That's not nothing to do with TDD. So the idea behind test-driven development has always been that we are essentially saying, what should the API of our code look like? If I am an external consumer of this code and I come to call it, what kind of API would I find useful? You're testing as much the usability of the API, how you interact with it, as you are essentially in designing that public-facing API as anything else. Okay? So you tell yourself a story about how this API should look if you were a consumer. The test becomes the first consumer of your code that essentially says, what should this look like and how should it work, right? That is the objective of test-driven development. Okay. So Kent uses unit test in a very specific way, right? And simply when he uses the phrase, all he means is that you should be able to run all your tests together as one suite without the impact, without one test being run impacting the other test. The unit of isolation is the test. And a lot of mistakes have been made because people believe the unit of isolation is the class under test. It is not. Okay. So all these people mocking because they say, well, you've got to have the class isolated when you test it. These all have to be mocks. You can't interact with anything else. You've got to mock all the class's dependencies, right? Because otherwise it's not a proper unit test. You are wrong. The unit of isolation is the test, not the thing under test. Okay. So one of the problems is people were using definitions from classical testing. And the thing is, essentially, unit tests referred to this idea of a module, right? And this is why it's a confusing phrase, because when people talked about unit tests, they were saying, take a module, so say in .NET terms an assembly or something, right? Take that, and then essentially test it on its own. Then an integration test is, I've got a couple of modules talking to each other, and then essentially a system test is all my modules talking to each other. So when Kent used this phrase, unit test, what he was really talking about was a module being tested. Okay. It's an unfortunate phrase because people then said, well, the unit is a class, and came up with a whole set of practice which basically has been negative towards our TDD practice. Okay. You may choose to avoid using certain interactions in testing, right? Databases, file systems, those kind of things, right? But the reasons Ken gives for that are slightly different from the ones you think. It's not about isolation. It's about isolation only in the sense that if I touch a database, then one test may impact another test. Because if I add some rows in the first test, when I read them in the second test, it may be impacted by basically the order they run in. So I have to make sure that between these two tests, I'm isolated from that kind of problem. Which may mean I choose to use something like an in-memory database that lets me tear that down rapidly and provide a fresh one for each test, right? But it's the isolation of the test that is driving that, not the isolation of the code under test. Same with file system and everything else. And the other issue is speed, right? Tests have to run fast. Otherwise, developers don't get fast feedback. So really I want my test suite to run in a couple of minutes. And it's quite possible if I'm talking to real hard dependencies that becomes hard. So I may wish to essentially swap those out for the purpose of basically speed. But those are the reasons for it. But there are others. If there is no shared fixture problem, it is perfectly fine in a unit test to talk to a database or a file system. Okay. And that happens all the time, people like Ken Beck's testing. So people telling you can't talk to database and unit test, they are wrong. Okay. Yeah, okay. Focusing on the methods creates tests that are hard to maintain, okay? Because essentially when I look at that test, what I see is somebody describing how you interact with a method. And that's why we get this problem when we come back to our test. They're very hard for us to understand because we're kind of going, well, what is this test doing? Well, we've got a method in isolation, so it's very hard to understand what it's doing. If the test tests a behavior, it's very easy to understand what that test is doing because it says this behavior is asserted to be true in the system. Now, if that test is read, because I've changed another part of my code, I can either say, well, that should still be true, or perhaps no, that isn't true anymore. That behavior's been modified now. We've added a new requirement, which means this behavior has also changed. And I've just seen an impact of that behavioral change. And when we have implementation details exposed, in other words, essentially all those things that make up how our API actually works, that's when you get this problem effectively of being hard to change, particularly if you use mocks. So when I use mocks effectively, because when I set that class under test, and I know about all the calls to other mocks, the problem is when I change something, that changes those, and all the basically assertions break. And if I essentially, therefore, know too much about my implementation details, then I've coupled my tests to my implementation, and I can't change one without changing the other. All right. So let's talk about how we get there, because the way we do this is really simple, and it's red-green refactor. Who thinks they understand red-green refactor? Okay, great. Who does red? How many of you make sure that essentially, okay, very few of you. Who does green? Probably most of you. Who then always does the refactoring step? Some. Okay, refactoring is the key thing. I have a test that doesn't work. Okay, this is important. There are no tests for tests. I have to demonstrate that my test will fail in the absence of correct implementation. Right? I've stumbled across this a few times. Had the problem where essentially I had a test that would always pass, and so essentially until that red phase, I wouldn't prove anything by writing my code and having it pass again, because it's always going to pass. Okay, green. Make the test work quickly, committing any sins basically necessary in the process. This is really important. What I'm doing is making the test pass by the quickest process possible. Okay. A good solution here, cut and paste code from Stack Overflow. Right? This is why the duct-tape programmer wins, because you're afraid to do that, and he's not. Do that. Okay. Now, basically make good code. But it's 3 steps. Write a test, make it compile, run to see that it fails, make it run. Remove duplication essentially is refactoring. Okay. When you write implement your test and you go to your green phase, what you are seeking to do is understand how to solve the problem. You want to basically, as fast as possible, get something that satisfies the behavior. I want to add 2 currencies in different amounts from different, and I want to basically look at the end result, right, in one currency. What I want to do as quickly as possible is figure out how to do that in my code. I just write what we call a transaction script, one line after another. Don't try and basically put it into lovely classes. Don't try and essentially put patterns in there. Just write line after line of code until it works. Okay? And that code can be dodgy if you want to be, and probably should be. Your goal is to, as fast as possible, get that test to go green, because you have managed to understand how you will implement the requirements. At this point, you are trying to determine how you will implement the requirements. And you can figure out the answer to that by going green. Go to Stack Overflow, copy some code. Right? You are explicitly enjoined in this step to write non-well-engineered code. You want to be the duct-tape programmer. You want to be that really annoying guy in your team who writes bad code. Emulate him. Do what he is doing to get out the door fast. You will now be keeping up with him. You've added a test, but yours is automated. He's probably having to do it manually a few times. You are moving the same rate he is now. Okay? Let's get back to this. For this brief moment, speed trumps design. I want to get there as fast as I can. Okay. Kent's point is essentially you can't do 2 things at once easily. You can't both understand the solution to the problem and engineer the code right. One of 2 things will go wrong. You will either over-engineer your solution beyond what the test actually requires, or you'll get some kind of analysis paralysis, right? But the first thing you do is just solve the problem with the code. Okay. So when are we getting our clean code? You know, right? Okay, so we believe in clean code. We don't want to have duct tape programmer code all along. So when are we going to do that? So the next phase, the refactoring step, when we produce clean code. So for Kent Beck, the key driver is duplication, right? You see duplication, you remove that, that starts to re-engineer your code well. That works. There you can add into that, I think, Fowler. Fowler's book Refactoring, we'll talk about that a bit later. Look for code smells. Okay, look for smells in your code that indicate there are better ways of doing this. And Joshua Karajewski's point is, if you want to think about using things like design patterns, this refactoring step is when you identify them, because now you have a clear idea what your solution is. You can tell whether a pattern is appropriate or essentially whether you're using patterns inappropriately as a solution. Okay. When you refactor, and this is the really important part, you do not write any new tests. Refactoring is a process of safe moves that let you essentially change the design of the code. They do not change its behavior. Your behavior is covered by the original test. The original test tells me I'm adding two amounts in two different currencies and getting the final result. The code that I'm implementing produces that result. If I use safe refactoring steps to get there, it doesn't matter how much I change the implementation details, I am still covered by my original test. Code coverage tools help you here because you don't want to introduce, for example, new conditionals, speculative code at this point. You need to be honest, and when you do that, you need to have new tests to cover those new behaviors. Because generally, you've got a conditional because you have a new behavior that you're trying to produce. But do not write new tests at this point. This results in two things. One, you will write less tests, so you will move faster. The refactoring step shouldn't take you so long that you fall miles behind this duct-tape programmer, right? You will keep up in the way that the lean software guys and your managers want you to, because you are not saying, oh, I'm creating a new class here, I'm doing extract class, because I believe that essentially these things should be a class in my implementation. Don't write a test for that class, right? If you have a language that supports visibility, for example, Java or C, C#, and you've got things like protected, internal, private, etc., public, right? In C#, for example, most of these will be internal. They're never exposed. And as such, the test should not be coupled to them. You should be at liberty to change their implementation however you like, and no test will fail, because no test is coupled to how you've done that implementation. And this is a key to understanding this, right? In the refactoring step, do not write new tests. You're not introducing public classes. If you basically keep thinking, I need to introduce a new public class, the only smell you may be looking at is that essentially in your solution there is some new thing that is also part of your API. Okay? That will itself be exposed as part of the API of your module. In that case, that's probably an appropriate time to think about a mock for use in your test, and later go and implement that other part of your API that you're currently missing, right? But focus initially on trying to avoid writing these extra tests. Okay. Kempeck says it, right? Dependency is the key problem in software. Right? Coupling is a worse enemy for you than dry. Coupling is what kills all software. So strive to decouple your tests from your implementation details. Focus on your public contract, your stable API, and leave your implementation details free of tests. And avoid heavy mocking. Okay. This allows you to meet the promise of refactoring. You will refactor your code and your tests won't break. Right? I've seen this work. Since I changed this practice, it's been very easy for us to refactor implementation details to figure out what new ways of doing things. We changed the whole way we did, for example, a modeling of an aggregate without any test breaking, because the behavior hadn't changed. Our choice about how to implement it had changed. Okay. So, test behaviors, don't test implementations. These mics are very annoying if you wear glasses. Right. Okay. Don't test externals. Don't make things public to test it. If you find yourself making things public in order to get it under test by implementation details, ask yourself if that genuinely is a part of the contract of your module. If it's not, don't. It's just an implementation detail. Why did you surface it for testing? If you are in .NET land and you use the assembly attribute, internals visible to, and list your test assembly so that you can get your internals tested, do not do that. Right? Your internals should not be visible to the test because they're not under test. Okay. So preserve your implementation hiding. Have a public API and then the internals. Right. This is Fowler's book on refactoring. It actually came out before Kent's book on TDD, and it talks really about code smells and says, here are some safe steps to be able to effectively refactor basically your code when you see these smells. And one of the key things to understand is, Fowler's very explicit, okay? We are changing implementation due to not public interface. Anyone ever use the DevExpress tools as opposed to ReSharper's tools for refactoring? So DevExpress, at least one of you. Okay, DevExpress have a set of tools which basically had a code plugins for Visual Studio, and they used to offer refactoring. And DevExpress's tools, I used to know some of the guys who worked on it, were very clear, right? You cannot refactor a public method on a public class. They wouldn't let you do it. Because that's change. That's not refactoring. Because you don't know the impact of that. Now later, they said, okay, you can press the button marked unsafe refactoring because everybody else lets you do it, and we're being killed in the marketplace. But also because they said, well, you may say to me, the only consumers of this public API are within the span of the solution, and therefore, essentially, I understand who all the callers are, and I can then refactor them. So if I'm doing a rename, I know who I'm going to break. But the goal was originally, don't do this, right? Don't change. Refactoring is not changing your public interface, it's changing how you chose to implement that. It is a safe, small change. There are recipes to do them. That's why tools automate them. And they're safe in the sense that your code is not basically going to negatively be impacted. If you extract a method, it's a safe change. Okay? Here's a list of user smells. It's not really what this talks about. But those are the kind of things that you're looking for. And those are the things that drive you in your refactoring step to do things like extract a class out of this basically transaction script body, extract a method out of this body, right? Look at basically where you've got feature envy, where you're doing some kind of dot syntax, etc., right? Joshua Karievsky, in this book, said there's a problem with the patterns, and the problem with patterns is people are getting pattern happy. They see patterns everywhere and start applying them. And in many cases, what they've done is applied them in the wrong context or made their software overcomplicated when they didn't need them. What Joshua Karievsky said is that the ideal step for applying patterns is the refactoring step. Because at this point, I know what the solution is. I've written one. It's an awful solution because I was told to make an awful solution. And at this point now, I can see I can clear it up by making a pattern. I can see that actually this is just the command pattern. I need that here. This is the template pattern. I need that here. But I know that now because I've already implemented it once badly. Okay. And even in Ken Buck's original book, he identifies patterns you may want to refactor to. Right, so this is part of the original TDD. This is not new stuff. Okay. So we're about ports and adapters. So this is unfortunately the common way that testing occurs in a lot of organizations. Before we release the software, there's a big wave of manual testing going on. Everyone's getting into the system, running manual scripts, etc., doing some kind of confidence releasing, right? Then below that, there's some sort of big suite of Selenium tests. Who has big suites of Selenium tests that they run against their software here? Not so bad, not so many of you, okay. And then we have integration tests. And at the bottom, we have a few developer tests, right? This is a bit of a disaster. Why? Well, first of all, this is really expensive and unrepeatable, so you really want to automate your way out of that situation. This one is very problematic, and I'll tell you why. If I change my UI to give it a nice, classy, new look and feel that's much more, 2017 rather than 2008, right? I may not be changing any of the behavior in my software whatsoever. They do exactly the same thing it did yesterday. I've just cleaned up the UI. But these tools all break. Okay? But I'm driving them to test the behavior of my system, but the tools all break because I changed the way that my widgets work. Okay? So they're very fragile, very expensive to own. They also run really slow. Quite often you run overnight, and then you get the blame game in the morning. Someone's job in the organization is to determine who is to blame for last night's test failing, right? So you find yourself in the situation where you have somebody whose job every morning is to determine who's to blame for the test failing. You are doing it wrong. I know that because I've done that, and that's wrong, okay? All the mistakes I'm telling you about, right, and I've made those. Don't worry, I'm not having a go at you because I think I'm smarter than you. I only know this because I've made every single one of these mistakes, right? So what you want is what's called the testing pyramid. The majority of your code should be tested by your developer tests. A small amount of code up here should test your widgets work correctly. And in between, there's a certain amount of integration testing where the two get hooked together. They're a bit of a scam in the middle, but we'll come back to that later. Okay? So, this is a hexagonal architecture. It's gained popularity recently. People like Bob Martin are calling this the clean architecture. Some people call it an onion architecture. There are various names for this architecture, various attempts at co-discovery of the same thing, right? What happens? Okay, in the middle, we essentially have plain old C# objects, plain old Java objects, plain old Python objects. I've not heard that phrase, popo. That's also slang word for the police in the UK, so be careful about using that word. Yeah. But these things are devoid of any technology concerns. So they don't know how to talk to the database. They don't know how to talk to the web. They're just basically completely plain old objects without any technology concerns in them. On the outside layer, we have what's called the adapter layer. The adapter layer knows how to talk to the outside world, and it has all the technology concerns. So you have primary ones over here, things like basically an HTTP adapter, so something like basically your web framework, web API, Django, Sinatra, effectively, or Flask, something like that, effectively, et cetera, or a GUI adapter, so like web forms or Django, something like that, right? And they talk basically to your domain. Over here, we've basically got a database that your domain uses to persist itself, and here we've got essentially the idea of things like sending messages over things like RabbitMQ or MSMQ, that kind of thing, right, or emails. In between is what's called the ports layer. So the port there literally is like a port in an operating system. I think it was a door. It's the door which essentially allows a boundary to be crossed. Here, it's the door that essentially says, well, my HTTP code needs to talk to my domain. It will go through this door, some kind of facade layer which lets me talk to it. Over here, it's saying, well, my domain code needs to basically persist the database. So I have a door that lets me talk to the database, some kind of repository model. Wrap up now? OK. Right. You give me 5 minutes more, and I'll just run through this quickly, right? Apologies for overrunning slightly. OK. So the port here is the ideal point to do for your tests. The tests talk to that port layer, not to the internals here. Because the port is how everything communicates with your code, and also is everything your code raises, like events or calls to a database. Okay? So the port is the point for you to make your calls. Integration tests are really just checking that essentially you can talk to this adapter correctly. You're configured correctly on this adapter. Don't test adapters themselves. They're usually third-party code. And a system test just checks that you can call from the outside in, right? And that is essentially how you do it. OK, make 2 quick points. I'll try to be very quick. Gears. So you may say, that's all great, Ian. Testing the API is fine, but I sometimes like TDD to help me understand how something's working, and I want to basically drill down using my TDD into the details. OK. So, connect this notion of gears, and here's how it works. So imagine I have 5 gears. In 4th gear, it's the process just described to you. You're testing the public API, and you're getting basically the full script out, and then you're refactoring that, right? In 5th gear, it's kind of like the implementation is very obvious. So actually, that refactoring step, when I write my code, rather than writing sinful code, I just write the correct answer. So it's a regular refactoring step. Be careful here. If basically you find that your coverage starts to blow out on your tests, shift down to 4th, because you're probably writing too much speculative code you haven't got tests for. If what I find, though, is that I'm saying, I don't know how to go green, I'm not really sure how to implement this, and I want to feel my way with the aid of tests to probe me a bit more, then shift gears down and write some tests to help you do that. You can also use things like a REPL. People use REPLs in languages like Python, etc., for this technique of just feeling your way a bit, but feel your way. But at the end of that process, delete the tests. The tests help guide you, but now they're a burden to somebody else coming along. The person coming along who wants to basically change the implementation details probably means that your way of doing it, they're changing it altogether. Your tests are now something they don't understand, which is protecting your implementation details. Throw them away, let the next person coming along write tests if they needed to take that implementation. Okay. ATD, well, very quickly, Kent Beck originally said don't do it because it has 2 problems. Customers are not interested, and it's very expensive to do, right? He later said when he had a book about ATD in his series, maybe I was wrong, maybe actually you need this because programmer tests are a problem, they don't focus on the gist of the system. James Shaw, who wrote Fit, said, he was one of the guys that wrote one of these tools, says, I don't do it anymore. And he said the reason effectively is that customers essentially don't care and they're a significant maintenance burden, right? So all these tools like Fit, Gherkin, that kind of thing, right? He just says, actually, if I have customers, I get them to help developers drive their developer tests. So the unit tests are informed by the developers talking to the customer and they write the appropriate unit tests. Over time, I used to believe in these tests. I used to think that it was worth writing a Fit and Gherkin test because and Cucumber Specflow test because I thought it helped keep developers honest. We knew what done was. But over time, I've come around to realize that probably what we were solving was the problem of how we're doing our unit testing. Because our unit testing was focused on methods on classes, we had nothing that told us about behaviors. But what we actually need to do is shift our TDD practice to be about behaviors, and then we can drop ATDD altogether. Just write developer tests in the same language you're using to implement, and drop these horrible translation layer between natural language and your code base. Behavior-driven development. Mentioned briefly that Dan basically created this thing called, had this original post, which basically it describes testing should be about behaviors. It is now a full-scale agile methodology. It's worth it being, you may be interested in that, but this talk is not about behavior-driven development as a methodology, right? It's taking that original kernel idea that Dan had of saying, test behaviors, don't test methods on classes. Mocks, briefly, mocks are useful when a resource is expensive to create and represents a shared fixture problem, but the problem with mock objects, essentially, is people have used them to isolate classes. Don't do that. And especially don't do this thing where effectively you say, I'm going to make sure junior developers have done the right thing by forcing them to use mocks so I can see how they implemented the method. It just couples your test to your software and means you can't change it. It's never worth it. Okay. Results are what we call unspecified software. Okay. Generally speaking, IOC containers are overused. Try and use them as little as possible. Only use them because your framework demands that you actually do it because they don't understand how to create objects that you have. If your framework was good, it would actually ask you to give it factories, not an IOC container, and you might implement your framework in terms of an IOC container. If you find yourself implementing IOC registration in your test, something has gone horribly wrong. Okay? A bit like ORMs, we overused IOC containers. Please avoid that. Okay. Right. Quick summary. Reason tested behavior is basically because there's a new behavior. I dirty code to get green and refactor. No new test refactors in internals and privates. Development set against tests written on a port. That's hexagonal architecture. Add integration tests only really to the extent that you're covering basically how ports are implemented. And don't mock internals, privates, or adapters are another one that we're missing. Add system at conference. Okay. I've run out of time for questions. I'm sorry. I'm going to let you all go. Please come up to the front if you want to ask a question at the end, or come and find me during the conference. I love talking about this stuff. You can see this talk online, versions of it given at places like NDC, so you want to share it with your colleagues, you can go and dig out the video. I think these guys are probably videoing it too, so you can share the video with your colleagues. It's worth going and looking at that conversation between Kent Beck and DHH, meeting with Martin Fowler as well, for a similar conversation about how it's all gone wrong. But thanks very much.
Thank you.